Good afternoon. It's great to see all of you, and it's a real pleasure to be here with you today. I'm Julia Sauter, the CEO of the Long Duration Energy Storage Council and the chair of the Global Renewables Alliance. And I'm really excited to share with you some perspectives of what's happening around the world concerning long duration energy storage, and also look forward to a great panel discussion about debunking the myth that we heard about today during the keynote. Let's see if this works. Aha, great. So the time is now. We've heard a lot about solar, we've heard a lot about storage, we've heard a lot about wind. But really, the momentum behind solar is really pushing the momentum behind storage, and in particular, long-duration energy storage that provides this flexibility that we need for all the energy shifting and to really deal with the load shedding here in South Africa. So what are we dealing with? This is not just something that's happening here in South Africa. This is happening around the world. What's also fascinating is that we have the political pressures on top of environmental pressures, on top of all the other layers. This is a unique year. Over 80 countries in the world are having political elections. That pressure point is also pushing forward different conversations about procurement, policies, climate, security, skills, adaptation, resiliency. It's really a game changer. And on top of that, last year was the hottest year on record, and this year will be the hottest year on record. Every year is building more and more aspects of the climate crisis on top of how we're dealing with different challenges and solutions. And the costs of every year in the climate crisis adds up. It costs the globe 93 billion US dollars in just 1 year of dealing with insurance, rebuilding, mitigation, adaptation. This cost is also going to increase every year. And so we need to balance how much it costs to be resilient with how much it costs to be more like inspiring and continue to build renewable energy and storage, and in particular long duration storage. So again, it's the cost savings the cost and savings benefits analysis that we need to keep in perspective. So one group that's trying to bring together the industry voice to work with governments around the world is this new association called the Global Renewables Alliance. It's bringing together the 6 CEOs of global solar, global wind, global hydropower, global geothermal, global hydro, and global long-duration energy storage, and green hydrogen. So the 6 of us have come together to work together to start providing solutions to the energy transition. How can we improve planning, permitting, and siting? How can we work together on jobs and workforce and upskilling? How can we work together on workforce development? And how can we work on supply chains and value chains? So as the fossil fuel industry is transitioning, the new clean energy industry is transitioning to take the space and own the dialogue and the economic benefits of the new economy. And what's amazing is just in 1 year, we've seen just the increase in renewable energy deployment. Over 80% globally of electricity was met with renewables. This is a game changer. This is something that's really starting to change the conversation. And just seeing here in South Africa, the deployment of solar and just the increasing values that are going to continue to grow, and how to match that with the load flexibility that we need. So in the international conversations that are happening, there was a big push at the climate negotiations to triple the renewables globally. And this is 11 gigawatts, 11,000 megawatts of renewable energy globally to meet the 1.5 degrees Celsius needs that our world needs to stay at before we go over the tipping point of the climate crisis. And so the 6 organizations work together with IRENA, the International Renewable Energy Association, to talk about how do we implement getting this huge goal of 11,000 megawatts of renewable energy to be deployed, and how do we bring in green hydrogen and long duration energy storage with this. It also includes doubling of energy efficiency too. So we worked with IRENA, we worked with IEA, and we worked with the COP president and the United Nations of how to make this work. We also wanted to highlight, this isn't just about building these projects and seeing the benefits of emissions reductions. There are a ton of jobs in the transitions that are happening, and a huge amount in sub-Saharan Africa. So this is also really demonstrating there's a lot of solar, a lot of wind, a lot of storage, and even more so, just this kind of integrated aspect of what we're working towards for this climate adaptation. And it can be done, and there's so much potential here. So as we really bring on all these renewable energy components to our energy systems, whether a microgrid, whether a remote system, whether a transmission system, we need that flexibility. And so we're starting to see that as we grow this outlook of increase of renewable energy penetration, we know that the power and demand system are not going to be in balance. We know that there's going to be constant delays with interconnection queues and transmission build-outs. And we know that there's also kind of this aspect of replacing traditional inertia with new renewable energy clean inertia with long-duration energy storage. And what's great is that to address all these challenges, we have a solution. It's long-duration energy storage. It really can give that flexibility needed to address the energy shifting that's happening in all different communities around the world. So what's also fascinating is that this growth in renewable energy is going to continue to escalate quickly. This is not something that's going to be small changes every year. This is exponential, and we're seeing this, just annually across the world. And in comparison with how 130 countries are really pushing towards this target of 11 gigawatts of renewable energy, we're seeing China just address these annually and how that will actually affect the rest of the world in the marketplace. I found it fascinating that in last year, China built the same amount of solar that the rest of the world did in 1 year. And so it just really kind of shows you the marketplace that we're all connected with. In addition to power, there's also heat. And this is really important because all economics, all industries really need power and heat to kind of move forward. Whether it's agriculture, chemicals, you really need to look at all these different components and where this heat is coming from. And as we're transitioning from fossil fuels providing this heat, we have renewable energy, a lot of solar providing this. And because solar doesn't work 24/7, you have to have long duration energy storage fill in those gaps. And so we're seeing that, the growth in renewable energy capacity, 510 gigawatts annually. We're seeing billions and billions, over 90 billion that needs to be invested in Africa to satisfy the 4% annual increase in demand. This is one of the largest demand growths in the world, other than China. And it's also really powerful to note that Africa's population will also be growing. It also has the wealth of the youngest generation in the world. So there's so much benefits and potential and opportunity here that the rest of the world can learn from. And it's also just really important to know that we have to keep this on track. We have to keep increasing the renewable energy and the storage in sync 2.5 times every year for the next decade. This isn't a small number, this is a big number. But we have to do this, and we are starting to do this. So just 2 case studies I wanted to share. What's happening in India, they have a target of 500 gigawatts by 2030. They're moving from security issues with oil and gas to really trying to bring in more local issues of what's happening with importing oil and what can they do with energy security using local solar, local wind, local storage resources. They really are trying to change the 80 gigawatts of thermal to thermal energy storage with renewable energy. And they're also looking at their annual demand of 8% each year of growth. So again, balancing the nexus and the trade-offs of moving from traditional energy to a new energy economy with renewable energy and long duration. And they're on the path. They're already halfway to their target, which is pretty impressive. China also, enormous numbers. They're also halfway to their target of 2030. 1,200 gigawatts. It's amazing. And just kind of want to show their potential in solar, just the land swath, but also kind of the need for this partnership. Some areas of grids in various countries are not going to have all the resources located in one area. So again, you need that flexibility. If you can't have the transmission lines, you need to have long duration energy storage at various substations to be a congestion management tool. Again, we're also seeing the investment of clean energy not just be deployed in China, but all over the world. And this is something that's also ongoing. Lithium ion is really important. It's a great short duration battery. Some lithium ion is moving into the 8-hour market. But that's why you need a lot of this new types of, and actually building on existing types of long duration energy storage to meet the 10-hour, the 24-hour, the weeks, the months, the seasons that you need to capture the solar in one season and use it as power or heat in the next season. So looking at the cost and kind of also just looking at the trade-offs, the council came into fruition to really bring together the entire ecosystem, demonstrate how long-duration energy storage can help provide society's benefits, really bring together the jobs, the workforce, the health benefits, the emissions reductions, talk about the partnerships among the different players within the industry of how we can work together to increase this global marketplace. So we're really working on identifying this $4 trillion marketplace, $4 trillion marketplace for long-duration energy storage, and the need for 8 terawatts of long-duration energy storage by 2040 to meet these goals. And so our members are very diverse. They're all over the world in various countries, over 20 countries. We really want to show that not only do we have the diversity of the technology providers, but we also have the diversity of utilities, financiers, investors, equipment manufacturers, integrators, developers, all part of the ecosystem to promote the value of long-duration energy storage. Some of these companies are new. They might even be in innovative stages of their TRL numbers 4 or 5. Others have been commercially deployed for decades. But again, that partnership is so key. There's 4 different types, 4 families of long-duration energy storage that we like to talk about. Electrochemical, these are the batteries, zinc, vanadium, iron, magnesium, organic chemistries. I like to joke that it's pretty much every element on the periodic table. And then there's thermal energy storage. So these are all the solutions that provide the rocks, the salts, the bricks, recycled aluminum, recycled cement that can hold heat for days, months, even years, have very high efficiencies. Chemical, this is where you have ammonia, but green hydrogen, kind of the nexus here, and then mechanical. Pumped hydro has been around for over 100 years. It's a very good long-duration energy storage. Compressed air has been around for over 20 years. And you also have all the different types of gravity storage, moving bricks, underground railroads, underground density of just moving liquids. There's a lot happening in all of these spaces, and we're pushing forward the marketplace to move them all forward. Because as was expressed earlier today, we have to debunk the myth that there's nothing available. There are tons of technologies that are available, tons of proven technologies available, tons of commercially available technologies that provide cost savings and many other benefits. But we have to break down the barriers to bring them into the market. I mentioned power, heat, and hydrogen. Again, this nexus of what long-duration energy storage can provide, that's why it can play in all these different sectors and industries. Provides that flexibility, that 24/7 element. Again, the interconnections of when a company might need a mining industry, want the heat and the power. Chemical industry, agriculture, same thing. We can really kind of improve the resiliency and build upon existing infrastructure. Some long-duration energy storage technologies can take an existing gas plant or a coal plant and reuse the infrastructure and repurpose it, so you can also kind of have that circular economy. So again, I mentioned kind of the different aspects of power and heat and how you can really get that firm heat or firm electricity. This is really important because so many industries need that continuity to really have the needs met so they can produce the goods on a regular basis, and you can have that firming with long-duration energy storage. You're going to see this later with other presentations, and I look forward to the panelists talking about this, but the role, again, of long-duration storage, providing the energy shifting, providing grid services. This is the power side. You also get a lot from the heat side. Again, noting that 8 hours, 24 hours, seasonal. There's even different types of long-duration energy storage that do really well with offshore wind, onshore wind, solar. It's really important to kind of see, again, that diversity of what you can use and what you need to adapt to your local geographies. And again, one thing that we're starting to see more in the procurement of utilities around the world is increasing the criteria for how long-duration storage provides ancillary services. Black start, frequency response, inertia. It's really important. Reserves and just short circuit levels responding. There's just so many different attributes that you can plug and play with long duration energy storage. Again, I mentioned the economies. Pretty much every economy touches long-duration energy storage and vice versa. I mentioned the 8 terawatt goal by 2040, the $4 trillion US marketplace, and there's a savings, an annual savings of bringing long-duration energy storage in. $540 billion annually when you have long-duration energy storage in the mix. We're not saying we're the only solution, but we are part of the solution in the whole kind of network. Again, energy shifting, we're going to talk about this a little later, but just how long-duration storage can promote stability for remote systems, for island nations, for transmission, distribution, investment, for deferment, cost savings. And then I want to go kind of a little bit more. When you bring on so much integration of renewable energy, many countries are at 30%. There are at least 10 countries that are at 100%, and there's about 15 countries that have already reached the 60% integration of renewable energy. That's huge, and they're already starting to see instability in their grid systems. Well, when they bring long-duration energy storage in, they're already seeing a cost savings, and they're starting to see how this really provides that flexibility, and that kind of, as they retire fossil fuels, they actually can see that they can bring in long-duration energy storage for that cycling, for that flexibility. Again, when you're comparing it to lithium-ion, we need the lithium-ion, we need different types of long-duration energy storage, but because long-duration energy storage assets are 20, 50-year assets, you get a lot of cost savings. They're going to be around longer. You're not going to have to switch out the materials. They're also very inexpensive. They don't catch on fire. You have a lot of safety aspects that are built in. And so as the duration of the number of hours you need over time, the costs stay the same. With lithium-ion, it increases. So this is a huge kind of aspect that I wanted to hear more from the panel on, what do you think about this, especially when we get to the 8 24-hour of long-duration storage. You see the pivot, you see the change of the benefits because of the diversity of what long-duration energy storage brings. So wanted to dive down a little bit more because the IEA, the International Energy Agency, just produced their World Energy Outlook, and they focused on countries around the world. And they're highlighting too just how fast the cost of batteries are coming down. We've seen solar come in 10 years, skyrocket. 5 years, half that we've seen costs come down for batteries. This is lithium-ion, but also bringing in other types of long-duration energy storage. It helps that the EV market has really pushed lithium-ion, and that's going to be really interesting as 5% of the lithium-ion industry is for power generation, the rest is for electric vehicles. We're going to see where this goes, but it's really helped bring costs down, and we'll continue to see the costs come down just because the need is escalating. I also thought this was interesting. The recommendations from the IEA for South Africa are showing how much potential is here, that as South Africa is working towards the 30 gigawatts of renewable energy integration, it's about 30% on the way there. What other things need to happen? So lowering the licensing threshold, and I really want to hear the panel's thoughts on this, whether you agree with the IEA or maybe we need to give them additional recommendations. But how to operate power plants with wheeling agreements that was also mentioned earlier, and bringing long duration energy storage as a possibility, and also continue to build on the auctions. Some of the auctions that were open, continue to implement the additional components to it, and really work faster towards removing the 12 gigawatts of coal in the system. There are a couple of long-duration energy storage projects in South Africa today, ones with Energy Vault and ones with Ambri. They are working and providing energy shifting, ancillary services, grid stabilization. One of them is completely off-grid, so it's a microgrid system. And it's just already demonstrating that there's benefit here, and that this is just the door opening to a lot more diverse projects being part of the partnership of solar and long-duration energy storage. It's also interesting that the SADC region's promoting the fact that long-duration energy storage is needed, and they're having competitive bidding with partners to really bring costs down too, and share lessons learned. So Eskom's also, as many of you know in the room, working on different tenders. We're really looking forward to the June tender having additional criteria for the 1.2 gigawatts of additional capacity of renewable energy and how that ties in long duration storage. the World Bank has also really helped with some funding. We're working with the African Development Bank to bring in additional funding for pilot projects and different projects in South Africa. And so it's ongoing kind of awareness, but also just now implementation to really get more projects built and come to fruition in the next 2 to 5 years. So I want to just share some things that the council's been doing, because we're noticing around the world how important it is to work on mandates and targets. It's great that we see renewable energy targets. We also want to see storage targets called out. So we've already done a lot of great work with our partners in Chile, $2 billion for storage, and really calls out long duration energy storage. They are already curtailing so much solar that they cost them in 1 year almost $500 million US dollars. The United Kingdom lost $1 billion in 1 year because they had to curtail so much offshore wind. So the curtailment is starting to happen with so much excess renewable energy that when you bring in long duration energy storage, it provides the savings. So more mandates have been really helping and more projects come to fruition. Spain, Greece, Canada, Australia, and these are just a few countries that are really pushing forward the need for mandates and public-private partnership and public and private funding. And then the World Bank also called out $1 billion US dollars for battery systems that has now been expanded to different types of diverse long-duration storage with different types of batteries. And then, there's a lot of work that Germany does in South Africa, and wanted to highlight that, we did some work with Germany and also looked at various case studies of what different policies can do to help trigger a market. How can it really help promote savings? And just saw that some certain policy changes have already helped in cost savings. So really trying to demonstrate that when you bring in long duration energy storage as a peak shaving aspect, it can also, with the right policy incentives, can make a difference instantly. So this is another aspect of just showing how policies, whether it's with grants or feed-in tariffs, can make a big difference when paired with long duration energy storage. So in addition to a lot of the work that we've been doing on policy mandates, we're also working on reports that really help demonstrate the value add of long duration energy storage. We've been working on industries, looking at mining, looking at agriculture and chemical industry, and showing that there's a lot of benefit with not just emissions reductions, but cost savings. And I'll give you a couple of slides here, but there's a lot more on our website that you can pull and look at and hopefully use for education and awareness. So if you're looking at some of the hard debate sectors, the heat that can be electrified, power coming from long duration energy storage, looking at mining, food chemicals, steel, cement, long duration energy storage can provide a solution in all these categories, working with our partners. And we go into the savings and CapEx and CapEx. We go into savings of just deferment of diesel fuels. We go into savings of what you can do with just kind of repurposing your portfolio. And want to just show that there's, we did some off-grid mining examples in Australia and a couple other countries that looked at South Africa, and just show again with how much savings you can get 1 year, 23 million US dollars, just how we can get paid back in a short amount of time with your PPA contracts. Instead of 10 years or 20 years, you get paid back in 5 to 7. And then, having an IRR of over anywhere from 20 to 40%. This is a huge game changer. This brings in the de-risk kind of conversation, and brings more banks to the table to talk about how they can be incentivized to help de-risk the funding aspects. And then also I mentioned, just operating expenses fall because you don't have all the O&M. You have very simple products that kind of really just, again, have longer lifelines and just a lot more positive economics. And this is the Australia case mining. Just wanted to highlight a couple things. The emissions abatement, just how many millions of tons every year that can be abated. This is also savings and RECs. Just how much diesel generation you can move off the system. This is also a security issue. Can you even get diesel? And really giving you cost savings there. There's the fuel shifting, and then just also the CapEx and OpEx costs, and just the fact that this one mine had a 76% reduction in OpEx by using long duration energy storage. Again, huge savings. So these are 4 reports you can find on our website. We have a lot of information in there about looking at different case studies around the world, demonstrating power, heat, and net zero industry, and many other aspects to show the value and the diversity of long duration energy storage. And we've talked about from different panelists today, and it was great to hear that Cape Town wants to be the first city in South Africa to stop load shedding. That's phenomenal. It'd be great to see. Here are some additional policy recommendations to help do this that we've seen be successful in various parts of the world. Having those long-term market signals are really important. Whether it's really having inclusive grid planning, whether it's having the renewable energy targets matched with long-duration energy storage, revenue mechanisms. Do you have a 24/7 clean power purchase agreement that builds in, again, the benefits of long-duration energy storage? Do you have different grants and incentives? Do you have different kind of market rules that are much more flexible to the adaptability of what the energy shifting that long-duration energy storage can provide? So we also heard about how important it is to have partnerships. The industry really wants to work with government, with different players to have that portfolio approach, that inclusive community benefit aspect. And we need to do this together, and we need to do this addressing the urgency at hand. We need that flexibility, and long duration energy storage can provide that. And we also are all working towards achieving these net zero targets. So no country's an energy island. We're all working on this together. We're all being affected by the constant impacts of the climate crisis, all the risks that bring us together to try to find different solutions. And again, just look forward to working with all of you and the partners on stage in the solar industry in particular, because there's so much growth in solar that it's going to need a lot of long duration storage to make it work 24/7. So thank you all. Look forward to the next presentation and look forward to your questions in the panel. There's some additional slides on here too. I'll share with everybody. Thanks. So I'll bring up, and I want to bring up Sabonoso to talk more about South Africa and renewable energy on your presentation. Thanks.
Thank you. Is the presentation
Thanks. Let me get my notes. The other way, sorry.
A very good morning to everyone. Thank you for inviting me. And I'd like to thank all of you for coming in, and I hope you enjoyed the presentation. I'm going to be talking about how can we address the intermittency in solar energy sources by the use of long duration storage. One of the aspects that we are facing today in the nation is the energy crisis. And we've seen what is happening in the energy crisis by the likes of load shedding. So hopefully by the end of the presentation, we'll have some take-homes and some of us will have the answers and the solution to our problems. So the overview of how solar energy production is intermittent in the entire network of, especially in South Africa, is renewable energy sources such as solar have gained a significant traction in global quest for sustainable energy. As you know that due to the global warming and the likes, we now have the need to bring renewable energy in the space so that we can try to reduce those carbon emissions in the entire continent and in the entire universe. So solar-based renewable energy sources generate electricity based on varying factors like the solar irradiation. Then the emittent nature of this energy produced presents a challenge in the balancing energy supply, so in the supply side and also on the demand side of the power system. The intermittent nature of solar-based renewable energy source can contribute to risk in the power system instabilities. So is it important for us to address this intermittency? The answer to that is yes. So we have to look at what does intermittency bring in the society and in the larger scale of the power system. So solar energy generation is inherently variable due to the factors such as the cloud cover, the time of the day, and also seasonal changes. So anything that can happen, because you know that solar is based on the sun and it's based on the irradiance. So the intensity of the sun now, if there is cloud cover or the cloud cover that is moving under the sun, then there's going to be intermittency. Then you're going to have spikes in the generation of the power, and you're going to have voltage flickering and then voltage reductions, and also voltage that are imbalanced in the system. So intermittent energy production can lead to imbalance between between the electricity demand and the electricity that is being supplied or generated. So what happens is, in most cases, so when you're looking at the solar scale, is now in a cloudy weather, electricity, you've promised to deliver 75 megawatt in the system. But due to cloud covers, now that cannot be easily attained due to the lack of intensity in the sun and the lack of irradiation. So grid frequency stability relies on the delicate balance between the power generation and the consumption. Usually, the balance between the generation side and the customer side, which is the client, and us that are consuming electricity, needs to balance. So whatever you produce needs to meet whatever is demanded on the other side. So if you produce more and there's less that is needed, then it causes imbalance in the electrical network. So if you produce less and there's more that is demanded, it also produces those imbalances in the electrical network. Hence, at times you find yourself in a load shedding wherever there is a lot of excess power that is being generated, but because of the demand is not so high, especially in off-peak hours, then we find ourselves now being load shed while we do have energy that has been generated. So why is intermittency a challenge? Let us look at 4 aspects that I've picked to look at those type of intermittency that are bringing that challenge into the network. So a sudden drop in generation, as in the case of solar. When solar energy production decreases abruptly due to the factors like the passing cloud that I've indicated earlier, or when there is sunset, because it's only solely dependent on the sun. When the sun is no longer shining, there is a rapid reduction in available power. Hence, there is a need for a solution to such a sudden drop in generation. Voltage fluctuations. The rapid change in power supply can result in voltage fluctuations affecting the performance and the lifespan of electrical equipment. Especially when we're looking at electronics and other electrical equipment, they don't like the voltage to fluctuate. They want to always have a balanced voltage. Hence, in South Africa, we've got the guidelines like the grid code compliance, whereby they will indicate that your voltage at a particular voltage level, it needs to range from a certain percentage to a certain percentage, so that all those equipments that are being fed by that supply, they need to be always sustainable. And then you can find a mismatch with the demand in peaks. So intermittency energy sources may not align in peak demand period. So in the likes of solar energy, we can only produce during the day. And also we can produce when there is sunlight. So for instance, you can produce, it depending on the places where you are, it might be different in Cape Town, it might be different in the Northern Cape, where you can start producing at 6 a.m. and then stop producing at 6 p.m. At other instances, you can start at 8, and then also with the seasonal changes, the time also different. So you cannot fully depend on that particular energy because it cannot be supplied at a constant demand. Frequency deviations. So grid instability can cause frequency variation impacting the synchronization of interconnected power systems. Electricity that is generated, for it to be transmitted from generation to the consumer side, it travels through frequencies, it travels through time. So in instance when a generator is being switched on to the instant when you receive it on the other hand. So there is frequency in between. So that frequency, in the case of South Africa, we are using 50 hertz. It needs to be maintained at 50 hertz for us to receive the electricity on the other side. So once there is imbalance or frequency changes in the system, it causes instability in the network, and it can also causes voltage fluctuations. Do we have a solution? One of the things that I've seen is to look at solution overview. In the dynamic landscape of renewable energy integration, battery energy storage system such as BESS emerges a pivotal solution to address the inherent challenges associated with grid stability and intermittency. This technology plays a transformative role in reshaping the energy infrastructure, providing a versatile and reliable means to enhance and integrate renewable source like solar. So what happens is, with us bringing in together the solar and the BESS storage, we can now harness the solar energy and then store it for a particular, in a particular way, which are the BESS storage, and then we store it in a particular time, and then we can dispatch it. That is why there is a term called as dispatchable energy. So a dispatchable energy is when we can store that particular energy and then be able to dispatch it over a period of time, and then in a certain megawatt. So typically, this is how a BESS look, which is a BESS advanced technologies designed to store the electrical energy in form of chemical energy. As our speaker here indicated, that there are four forms of long duration storage that we have. In those long duration storages that we have, part and parcel of it is the chemical storage part of it, which I'm going to talk more about, which is the BESS solution. This system consists of various components, including like the batteries, it includes your inverters, it includes your control system. So at the end of the day, as I've touched before, that there is grid instability. So you need to control this system so that the output and the output from the BESS is always the desired output to the grid, especially because in most cases we're going to be supplying this to the grid, and the grid needs to be stable at all times. BESS is a long duration storage and grid balancing, or the grid stability. BESS plays a crucial role in transition to renewable energy by addressing the intermittent nature of sources like solar. This solar system provides a reliable and flexible means of storing excess energy generation during period of high production, allowing for the utilization for surplus energy that will otherwise be wasted. You're looking at the graph, which I'm going to show a little bit later, when you're looking at how solar is generated. So solar generated, it peaks and then it goes down. So when it peaks, in most cases, you'll have a power purchase agreement. For instance, you will have a PPA of 100 megawatt that you need to supply to Eskom or to a private off-taker. But in most cases, as engineers, we design or we over-design the plant so that we can at all times meet the desired capacity. However, at times, when there is good irradiance, which is above 1,000 watt per meter square, you find that there is a wastage of electricity or wastage of energy that has been generated. So that is where BESS comes in to say we can take that energy that is being wasted and then we can store it, and then at a later stage we can dispatch it. BESS contribute to grid stability by acting as a buffer, absorbing fluctuations in energy production and demand. BESS contribute to frequency regulation by adjusting their output in real time, ensuring that the grid operates at the desired frequency. There is energy or power arbitrage, which is in South Africa at the current moment is not so common. However, it is something that in the future we need to look at, especially in the context when we're looking at the grid side of the network. You often hear they talking about grid capacity that in South Africa we don't have, especially in the transmission line, we don't have enough grid capacity. That's why in the round 7, some other parts, like likes of Western Cape, the west of Northern Cape, there's no longer enough grid capacity for a renewable energy to come and connect to the network. What happens is, if you've got the battery storage or the BESS system, what you can do is we can have an agreement, for instance, looking at the IPP side and looking at Eskom side. An IPP can go and build a solar plant with the intention that they want to dispatch this particular solar. You can have your curtailment, particular solar at the later stage. So you generate during the day, you're not charging Eskom, you store the energy, then at the later stage in the evening, you dispatch that energy when in the peak time, when the energy is needed the most, or only you can dispatch when the energy is needed the most, or in the instances whereby maybe one of the coal plants is down and then there's excess energy that is needed, then you can dispatch that particular energy in that period. And then in the case of Eskom, which I've seen happening in one of their substations, is you build the battery storage closer to the substation during the day, when on off-peak times, when you don't need the energy the most, you store the energy. Then during the evening or in the peak period where you need the energy, then you dispatch it, you push it to the grid. Then you can have that supply for that particular period. So there's also a term of energy shifting, where also it's a similar concept with the arbitrage. However, in this instance, you don't do the selling of at a higher cost or the buying at a higher cost. It's just a matter that you use the excess energy that you have during the day, and then you can dispatch it either in the morning or later in the evening. And then only the day you're focusing on having the excess energy, storing that energy, and then you dispatch it. As I conclude, in summary, long-duration energy storage enhances the effectiveness of solar generation by providing a reliable and flexible means of storing and deploying excess energy, ensuring that a constant power supply and contributing to the overall stability of the energy system. Together, solar energy and long-duration storage from a powerful combination of sustainable and resilient energy future, we can win this game. I'm standing here, I don't have all the answers, but I believe that the panel that is here and everyone that has joined us here, we will fight this together and make sure that the future, especially the future of South Africa, looking at it as a global player in terms of fighting the crisis that we have and the load shedding that we have, we can have the solution and bring the future together. Thank you.
Thank you so much, Samuel. So that was a great presentation to kind of show the fluctuations that we have for every hour and how we can all start addressing and working on this together, especially with the leadership of South Africa, of how much the resiliency is just demonstrated over and over again, how we can really adapt that to deploying long-duration energy storage. So, Joe, I think you had a question that you wanted to ask about the presentation earlier, or that you wanted to highlight some of the criteria for the flexibility needs of the procurement that South Africa could really promote long-duration energy storage.
I think, Julia, I'd like to talk on the overall and actually the status quo of South Africa, because I think that one of the key things that I want to reflect on is, yesterday we had the CEO's breakfast from the DMOE, and the DMOE being obviously the custodian of the South African grid per se, or the energy path, or the mix of energy products that we have. And I think one of the big, I wouldn't say it's an elephant in the room, but one of the big topics currently in South Africa, it's a hot topic, is the IRP, which is the Integrated Resource Plan. And the Integrated Resource Plan, just from a principal point of view, is a model based on Plexus. Plexus is an internationally acclaimed leading energy modeling software system that looks at an energy path, and it looks at an energy path of where we are today and where we want to be in 2050. It looks at multiple factors, so it takes a techno-economic, all kinds of criteria. And if you populate that with a South African context, then one has to look at what is the end state? And I think a lot of the times we neglect to look at what is the end state in 2050. I heard you making references to 2050, and where is the South African grid off to? So what we have is, in South Africa, and I know everybody maybe doesn't want to have all these terms, but we have the energy transition. The world is doing an energy transition globally. The leaders that we can take lessons learned, but then one has to take it back home and look at what is the current situation here. We have a second part where we've had a vertically integrated state-owned entity that has not controlled, but produced the energy resource for South Africa. And it's been based on one set criteria, which is obviously fossil fuel based, which we understand, but it's on a very centralized basis, if you look at it. So once one wants to unpack that and you want to go down to the distributed generation level, you're sitting with the constraints that the transmission grid itself and the distribution grids have got complexities. And if we look at the current status quo where we are now, I think it's public knowledge that we've got load shedding, we've got multiple complications. You have to then relook at the technology mix. And I think a lot of people defend maybe one technology above the other. And I think maybe you should park all of that and you should look at what the grid needs. Because if we're going to expand the grid alone in South Africa needs almost R1 trillion then to be able to expand it on the current process of generation. If one then looks at the distributed level, you've got to look at what would be the transition, right? So in walks the renewables, which are the drivers, because we've got compliances on another level. You must remember that South Africa has made a very, very, very aggressive contribution to climate change, to COPs, right? So our nationally determined contribution has set us on a path that's unattainable if we continue on the trajectory now. So if we're going to meet that in 2030, we've got that driver. Based on that as well, we've got maybe the lack of funding for better purposes to be able to transition to that. The first stepping point would be to absorb, obviously, the variable technologies, which, if you put it into Plexus, says that solar and wind become the least cost technologies, right? That's great. But the grid can't accept that, and which the gentleman has very aptly explained. So then you're going to have to look at what's going to be the platform that's going to transcend it, and it would be the storage. Hence them putting storage into the Plexus. But when they put the storage into the Plexus, it didn't define the technology basis. And I think it's that when, if you reflect on, maybe I was a bit facetious this morning saying, if people reflect on batteries, it's the Duracell battery. But that's the point. It's that there's no exposure to the variables that could be, and we're not looking at modeling according to that. And I think it's because there's an almost, and I'm not going to be blunt to everybody here, but it's almost like a defensive, reactive, knee-jerk reaction and saying, I'm going to defend my technology. So I'm going to focus totally on, I wouldn't say the word is punting, but for a better word, this is the one that we have, and we're inclined to go with the path of least resistance, and sort of the technology we know. And we don't have enough exposure into taking that next step to go there. What's changing here, and I'm speaking from a point of good insight into this, we've got, at the presidency, we've got what you call NECOM. I'm sure you've heard about it as the National Energy Crisis Committee. We all sit there on various levels, and obviously SAISA, being the South African Energy Storage Association, has got good representation there. So you're looking at multiple silo mentalities where we're saying, this is the transmission grid, this is what the transmission grid has to do. This is what one of the committees that I sit on is wheeling, you know what I mean, to be able to unlock the grid to get the financial transactions for the wheeling. But nobody's actually really looking at the modeling of the technology base as unpacked into the different elements. And I think that's why we sort of welcome you, and it was really refreshing for me this week to actually just meet you, and I'm being very open here from a South African Energy Storage Association, that we haven't had the exposure to what are the next steps. So if people are resistant now, it's really because everybody's sort of almost standing behind a rock and observing, you know, what can happen. And you have these statements about first movers and third movers. And this is why I sort of table that project that I'm doing myself, because it was really to make that statement. So if we had to talk about long-journey energy storage, we would need to have that exposure from the contributions that you would be able to provide from the world part in that, and be able to explore it with everybody that's here. Because I think we're not looking at what the limitations on the grid are. The limitations on the grid are serious. Yeah. We've got 17,000 megawatts that we need to convert. We've got an energy available to the grid currently now of 48%. So if you look at the current generation at 48%, any country at a normal basis should have 85% generation available to the grid. Actually, you should be at 100%. If you had to look at that funding gap, and I was very interested in what you said about international funding, international supports, and that. If you had to look at the funding gap that our monopoly now has, they need to come up with 1 trillion rand to be able to bridge from 48% to get us to 75%. They can't go the fossil fuel route. We're stuck. We're snookered. We're in a corner, and we can't remain on the centralized basis. We've got to deploy it out into the distributed basis. The only way we are going to get that is by the public-private partnerships. The public-private partnerships are going to be driven by your intensive energy user groups, which is formed of your large user contributions. The disparity that we have there is that 40% of the South African consumption, energy consumption, is the large intensive users. 60% of energy consumption is from the municipal level, which is your domestic and your residential market. So it's this subsidized criteria, because you're not going to change it at the municipal level, you're going to have to change it at the 40%. So the 40% has to pull the 60% up, if you had to think it from a grid level.
So Joe, you just went through a long list of what we can work on to improve together, and what South Africa can also look at different perspectives. Your number one point of planning is key with the integrated resource plan and how it's such an important tool, and the inclusive aspect of the right criteria in the integrated resource plan. Talking about the modeling aspects. Are we looking at the right models? Are they really looking at the diversity of different technologies, including long duration energy storage and the benefits they can bring? Looking at different scenarios. What are different options for the 60-40, 40-60, the different customers and partners? And funding. How are we going to fund this? You talked about transmission and distribution. The seams issues are so important, and they're different systems, and there are lessons to be learned throughout Africa, but also other parts of the world, because this is an issue that so many different utilities are working through daily. And how can long duration energy storage help with deferment of costs? We need infrastructure, we need new transmission lines, we need all these pieces, but at the same time, that inclusive planning can really help look at all the different pieces. So, thank you for bringing up the tools that exist and how we can bring more attributes to improve them to help with the crisis at hand.
And basically that, and basically the support for the leaders that are going to have to put the technologies down. And that's really going to be from a private sector. It's going to be from taking a mine or taking a foundry or providing sustainability from them. So you've got to be able to prove the financial case. Because, at the end of the day, whether we want to accept it or not, the pricing of the NPV value, can I say, or IR value, for any of them to entertain any of these solutions needs to be positive.
Right.
We know that we can make it a positive contribution, but there's no base cases here for us to be able to prove it.
There's a lot of positive attributes that we can all bring together, especially when you saw the graph that Siminoso showed earlier of the every hour of shifting and how we can actually address that. There are tools today to address that shifting and that flexibility. And Herman, you're working on a variety of tools too with Huawei, and you've been talking a lot about flexibility in the last couple of days. Can you give some examples of what you're working on to address flexibility, and maybe some of your input to the planning and attributes that you saw in the graphs earlier?
Thank you, Julia. Renewable energy, I would just like to start off by saying, honorable guests, ladies and gentlemen, thank you for the opportunity being here today. I'm from Huawei, a product manager senior, and I stumbled across the article dated around about 1986.
Yeah.
Pretoria CBD was out of power for 4 minutes. How sad indeed. I look at our infrastructure from gigawatts down to only a mere 22 gigawatt of energy available. And then I would like to just draw our attention that renewable energy is the use of energy in the lifespan of a human being that can be reused. Unlike fusion fossil fuels that take billions of years to replenish, renewable allows us to shorten the period. The introduction of solar alone gave us a cycle of 24 hours. Introducing energy storage allowed us now to shorten the lifespan as fast as possible. I'm coming back to Julia's question and data referring to 50 gigawatts of South Africa. Too little, too late. I'm going to put the example down to you. Round 3 projects was announced in South Africa, around about 4.3 gigawatt of power to be introduced. After the first year, it was remapped to 1.2 gigawatt, and eventually the solar project of round 3 ended up in round about 400 megawatts of power. Each time there's a delay of rolling out this, we are pouring and suffering more. We as Huawei have shipped in 2021 to 2022 globally 16.3 gigawatt. In my existence at my previous company, we have developed 800 megawatt in round about 8 years. Huawei, we have done round about 540 megawatt in 1 year. It is shocking to understand that we take so long to adopt to it. Yes, we have spoken a bit about the qualities that it brings, the sustainability. But at this stage in South Africa, there's 5 models that make solar pay. The first model is to maximize self-consumption. Once you can extend the daytime by including energy storage, you can have a business model. The second business model is what we refer to auxiliary services. Once you can improve frequency control, voltage control, you've got a business model. The third one is what we refer to time of use, if we can extend peaks and swell banking. The fourth unit, what we've got is maximum demand. 3 of these units do not even require any additional PV. And then the last one that's got the most valuable in the energy sector today is to avoid expensive grid reconstruction. As you have mentioned, what do we do if we don't have the transmission lines? How do we wield this energy? How do we offset it? And therefore, currently, the biggest financial model to make ESS work and make a lot of money in South Africa is avoid expensive grid reconstruction. So from Huawei's side, thank you for the picture of the battery system. We have seen in the energy sector, especially BESS systems, 5 major risks that is appearing in South Africa. We've got this massive state of charge, calibration. As we're moving away from parallel connected batteries, we are now attending high frequency series connected batteries. This technology is not that easy to anymore have a state of charge that can easily be balanced. We as Huawei have seen up to 15% in differences between the uptake and the discharge of energy storage. Secondly, we have seen a massive amount of solutions that do not address the temperature issues in containers. You can see on LinkedIn posts of centralized air conditioning sitting on one portion of a container, but have up to 10 degrees of differences inside this container. We have a customer that have a degradation of up to 50% within 3 years that was due to only temperature differences in the package or the storage solution. Thirdly, we have seen in Huawei extremely high amount of fires. In the Johannesburg CBD, the last figures is up to 7 fires currently just due to energy storage. And then on the fourth reason, what we have seen in Huawei as well as expensive operation and maintenance. Ladies and gentlemen, taking up energy storage and bringing a solution will need you all to readdress and look at what you're going to bank your products going to forward. It's an expensive solution at the end of the day, but it's the only alternative we've got to bring security into the network we've got at this stage. So I would love to see this 50 gigawatt being rolled out as fast as possible, because the sad story is the leaders currently is in the industry and commercial and industry space. They've got a very sound financial model to offset the energy and have a low ROI. And then again, taking consideration we were sitting with our networks and how far they are away with the stability of the infrastructure, it's going to be a challenge to wheel it to the right positions in our country.
So we've heard about challenges and 5 different models of what we need to kind of look for and work through. We've heard about planning and modeling aspects. So Manoso, you showed the graph of the grid fluctuations and the hourly matching that we need to have. Now hearing about some of the hurdles and the need that South Africa has set goals but has retracted on some of these. What can we do to move forward to address these challenges but move faster?
I think, Julia, I would say it's a bit political, but I would say it. I was a bit disappointed with the bid round 7 that was announced lately. We've seen in the risk mitigation when one of the plants, I think it was a 540 megawatt, there was 150 megawatt of dispatchable energy that was introduced, where I think it was 1.2, if not 1.1 gigawatt hour of battery storage that came along with those solar PV plants. So I was hoping that in rolling out of the blackout and also curbing load shedding, the next round, when we're announcing that we are still going renewable energy, each plant was supposed to go and be said it's going to be a dispatchable power plant that goes, so it should have been made mandatory at least for each plant to have a battery storage for that bid, so that we know that at least 2-3 hours of dispatchable power we have, and we can play around with the times when we need and when we don't. So not necessarily that in the case of solar, when we don't have this, the sun, then we dispatch it. We can wait a little bit, then maybe at midnight when we need it the most, then we dispatch it. That is the first point that I'm thinking, that we should be moving towards direction. I think the talk we should be moving to say, where is battery storage fitting in? Is long duration storage something that we need for the future? The answer is yes. However, is the direction and the talk that needs to happen in the background to say, this is the direction where we move. Because now we are having solar and wind, that in the announcement they introduce curtailment. Why are we not introducing curtailment at the same time saying, let us have a battery storage at the background to say whatever we are curtailing, we can save it and then dispatch it later.
Yeah. Your point on curtailment is key. Every time we give away or lose free energy, we're just costing communities and the country money. And 1986 is a while ago, and the fact that there was initial load shedding back then, we want to hopefully that we continue to learn from lessons, not have the backtracks that are hurting our communities and our country. And so how can we provide this flexibility in the incentives to really not miss a target again? Because every time a target is missed, it costs a lot of money, and it costs lives, and it costs benefits to the country. So is there a way to bring in, different market tools or mechanisms or different packages of incentives that can really help bring together this addressing of curtailment, addressing of grid infrastructure, and addressing of meeting targets on time, so that you can have the costs come down for different technologies? Hard question, but if we can answer this, then it's part of the solution for everyone to take home. Go ahead, Joe.
It's linked to the cost of supply studies.
Cost of supply
So South Africa's transmission development plan that Eskom tables, because they remain the custodian of the transmission network and the distribution networks, right? So there's different interval points within that, because it's tabled to look at where the load centers are. So we have a disparity in South Africa of where your load centers are. So where, say for instance, with all the IPP projects, and why they're bringing in the options of the curtailment is that your prime area that everyone targeted for the solar production was possibly the Northern Cape, but the Northern Cape doesn't have a load center. The load centers are in Gauteng and the different areas, so there's nothing to absorb the load. So this is why they're introducing it. So there is a disparity in the transmission network upgrades, and what the key study that needs to be done is to look at what interval points and at what intersection points do we need to put the long duration storage. So we need to start having conversations about whether it's going to be co-located or standalone, so that it can provide those intervals, because you need to bridge that platform. So if you had to change the transmission network as we have it now, as I said, it's going to cost a huge amount of investment, right? So you've got this disparity now with every IPP. If we wanted to talk about an IPP is connecting at a specific point, but it has to actually then accommodate, to be able to evacuate into the grid there, it has to accommodate as part of its costs, its capital costs, transmission upgrades further up into the grid. And this then makes the viability of the project null, right? Yep. So now they step back. So if we had to change the perspective and we had to look at the storage allocation, and that's what I said back again to you, is we have to unpack the available types of storage, because you need to have co-located various technologies at different interval points. And that's where we're not seeing the procurement rounds, because the procurement rounds come out and then come out again and come out again, like you saw with the Renewable Energy Emergency Power Program. So there was the one option that everyone bailed against, which is obviously car power ships. Nobody would really want to see the car power ships. But if you had to take the technology of what the car power ships would have done and applied that into more conducive technologies that are more acceptable from an environmental perspective, you could have actually applied that resource, and we didn't. So we're limited in the sense that the monopoly dictates the technology, and not the technology dictates into the monopoly.
So what I'm hearing is maybe we don't have to take as many steps backwards because we can improve the criteria for the procurement so that you can look at the diversity of options for the connection points with IPPs, with utility substations. There's different co-location that can happen. And if we have the incentives for different zones, this could help move us forward versus back. And Herman, I saw you deep thinking over there. So what are those thoughts you want to share?
I would just like to say that for me, being engineer, the way to move forward is augmentation. You need to start partnering with a solution product that can actually give you scalability and augmenting and offsetting your cost over a period of time. Pitching in at a very expensive project can cost you. And if I even look at the picture that was shown, I do see a lot of flaws in that design. Huawei's products that is able to be staggered and augmented over a period of time allows you to start with a low amount of energy storage, costing your project way cheaper. And then, as you've mentioned in your slide, Julia, lithium is rapidly decreasing. Yeah. So why would you start your project with an expensive battery solution sitting at billions of rands, we can start immediately with a project costing millions of rands, arguments. And then over the time period, interface with new battery technologies, or later more storage. Unfortunately, if you're not going to use the right product, you will not be able to scale it. You'll not be able to introduce battery storage of a different type at a later stage. Now, there is ways that we do it. There's ways that I am convinced that we are offering the best. And for me, on a technical level, partner yourself with the right technical solution from the beginning. Otherwise, you're dead in the water.
And I think really being able to plan well so you know what solution you want, correct, knowing that there's diverse options out there and that there's so many today that can really help you with that circular economy. If you're stuck, you can actually maybe pull apart pieces and repurpose it for later or yes, reutilize it for the cost savings. So I'd like to ask each one of you, there's key decision makers, investors in the room who want to take away a golden nugget of what the LDES can be for them. Would love to hear from each of you is what's the golden nugget you want to share with the group to help them understand, take away a benefit of long duration energy storage and flexibility. Siminoso, I'll start with you.
I think, Julia, we are at the stage where we do have the technology. We do have the expertise. The will needs to come from the buyer side and the seller side to meet each other halfway. To say, for us to make this thing work, let us find ways of decreasing the price so that we can install more.
Love it.
So that's what we need.
Partnership.
I would like to say that looking at the different areas in South Africa and municipalities, there's no transparency. Western Cape is pushing for legislation on one side, Tshwane is on another side, Ekurhuleni. And it's quite frightening to see that a lot of these government institutions do not have good transparency and a good idea of going forward. So we definitely need to have more sub-forums, more open discussions, and trying to bring the value, because at this stage it feels like me it's a locked up solution where we are only isolating it into certain regions, where we need to open the whole country if we're going to bring a solution, because the sun is shining on all of us, and as the sun is shining on all of us, it's shining on different parts of our country as well, and we need to capitalize on every free array of sunlight.
Love that. Working together, making sure that we kind of know the challenge points that are already there, just how to really maximize the benefits that are around the country. Joe?
I think I'd like to dovetail on what both my esteemed colleagues here have spoken about. And I think we just need to take it to another level. We need to be frank, and we need to be, I think, far more blunt in the fact that there's no regularity barrier at this point in time. So if I want to reflect again on my case in point in the IRP, if we call for comments and we call for support, I think that the SA market is maybe so despondent. It's not responding. We're more looking at why it won't work as to why it will work. And we're not getting that feedback that we require. And we really need, I would say, the OEMs to step up to the plate. I think that they need to put aside vested interest approaches and collaborate more on a greater scale, because there's a lot of pie there for everybody to have, but at the moment everybody's defending their small little, sort of place under the sun. We're not seeing that collaboration. So if you have to reflect on, I think Cameron said now about Tshwane, and I just came off a very interesting call with, say, for instance, Tshwane this morning. The municipalities don't have that intellectual capacity. And I'm not saying this with any disrespect to any of them. And Eskom has to look at where it's seated. Unless we provide these and come back with the responses, and unless some of the people actually take up the challenge and say, I think you said one technology might be in the region of billions and the other one millions. We need that partnerships to be able to prove it. So it really is, like I said to you before, it's about the one that goes first. The one that goes first will be the one that will be replicating, and we're not seeing that. We're going to stay in the humdrum, we're going to have these conversations, we're going to have these plenaries, and we're just going to keep on repeating it. So if the International Council, and I put the challenge out to you, Long Duration Energy Storage Council, wants to come partner with South Africa, there's enough platforms where we can create that transparency. There's enough conversations between NERSA, between the utilities, between the presidency, between everybody, I think maybe keenly seeking solutions. And it is about where that energy advice comes in, it is about that information. So we know it exists globally. We need someone to come and explain to us how to make it happen locally.
That's a great invitation for partnership, because as the panel has highlighted, that we cannot afford to take any more steps backward. It's costing the country too much. It's hurting the communities. It's really detrimenting the economy, and that there's so many other attributes that we have the tools, we have the platforms, we need to make them more transparent, and that we really do know where the challenges are with the transmission grid. We need to really improve the infrastructure. We know that there's areas, and with remote systems, distribution systems, the seams issues, the transmission system. But what's amazing is that there are options, there are solutions that are available today. We can build on the existing integrated resource plan, the regulatory tools. We can bring together, make sure that OEMs are communicating with IPPs, the world of acronyms. They're really making sure that all these players are at the table, because again, that urgency is so important. And it's really important to look at the diversity of options, whether it's lithium ion for short duration, whether it's the electrochemical, the mechanical, the thermal, the chemical. There are options available today that are commercial, that are willing and want to be part of the market here, and they really want to provide the benefits of the jobs, the health, the emissions reductions, there are ways to address load shedding. There are tools. We just have to make sure, from what the panel has said today, that we use the existing platforms, the tools, and really keep pushing forward, because any more delays can really hurt the marketplace. So just want to thank you all again. We have a lot of great options and insights, and look forward to working with the South Africa Energy Storage Association to really bring together more scenarios and lessons learned, highlight the great work that's happening in South Africa when we start meeting the targets, and to highlight to the rest of the world how resiliency shows up in different ways. It's a great way to kind of share knowledge back and forth. So really look forward to seeing all the progress that South Africa makes to promote the value and the benefits of long duration energy storage. So thank you all so much. Thank you. Have a great rest of your day. Thanks, guys.